Welcome everybody. My name is Lee Stas. It's great to see so many people have registered for this. Over 100 people have registered for this. This is probably the biggest community of practice that we've had to date. For those who don't know me, my name is Lee Stas. I'm the Manager for Research and Innovation at Sydney Water. And today we have some really two special guests that are going to talk about the projects that they're working on. And really there is a research side to this discussion and also an industry side to this discussion. A little bit of housekeeping before we get started. Each presenter will be given about 20 or between 15 to 20 minutes to present on their project. There will be time at the end of each presentation to ask questions about the project. I'll just ask people to put their cameras on and their mute buttons on as well. Thank you. And so if you have any burning questions, please put it in the chat. But we will make time at the end of each presentation to have a discussion. And then towards the end of the actual community of practice, we've made some time where we can all have a discussion about where the research gaps are, what the lessons learnt are, and how industry can integrate the translation of the research outcomes into practice. So without further ado, I might get you, can you just introduce yourself? And then I'm going to get Sujeeva to introduce herself, and then we'll get into the discussion.
Thank you, Liz, and good afternoon, everyone. Thank you for joining us today. My name is Koay, and I am a structural engineering advisor at Major Root Project Victoria. I'm excited to have the opportunity to present on intelligent asset management of concrete bridges. This is quite important subject and quite hot topic discussion within the industry at the moment. In my role at the Major Root Project Victoria, I provide technical support and advice on the root and related structure. With more than 25 years of experience in civil and structural engineering, I have had the privilege of working on this topic with the RMIT University. Just a disclaimer, the view of the opinion expressed in this presentation are my own and do not necessarily reflect those of Victoria State Government, Major Root Project Victoria, or any other affiliated entities. Before I start, I just would like to acknowledge the traditional owner of the land on which we are meeting. I pay my respect to the elder, past and present, and the elder of other Aboriginal community who may be here today. Just give you the content of my presentation today. I will give an introduction and we look for an overview of the asset management. What are they? Also move on to the challenges in managing concrete bridges. As you know that concrete has been used for many years, but always got the challenges to understand the behavior from the material from the structure. Then I move on to the intelligent asset management system and address some of the key technology and tools we have used it for our structure. Then will come out some case studies, then look into the benefit and future trend, then draw out the conclusion after that following Q&A. Just go to the introduction. The objective of this project is try to explore the role of the intelligent asset management in maintaining and optimizing the concrete bridges. And the most important, we would like to ensure the longevity and the safety of the bridges through the advanced technology. We look for the overview of the asset management. When we are talking about asset management, what does it mean? The asset management important, we need to have a systematic process of the maintaining, also upgrading and operating the physical asset with the cost effectively. As you know that for the budget for maintaining the structure is getting less and less. What we need to have some sort of systematic approach and come out how to optimize it and how to bring the structure can last for much longer. And the key component in here for the asset management is important is the data collection, analysis, and decision making and implementation. If you don't have the data, it's very hard for you to analyze it. So data collection is the most important. Sometimes you have a lot of data, but if you don't really analyze it in the right track, you may misinterpret and not really bring any value to do it on the asset management. The third part I think is important is the decision making. Who can make that decision? Either intervene the structure or use the alternate option to maintain the structure. Then come to the implementation. The purpose on this one all together is the life cycle management. We want to ensure the bridges are function, safe, and meet the performance standard. That is quite important thing. This is quite interesting. I read the news yesterday. I thought to share to everyone. In the Victoria, you can say that Victoria region will face ongoing growing pain because of aging infrastructure and the booming population. You can see that our structure is getting old and older, but the population is getting grow and go. Means that our old structure need to accommodate more vehicle or more population on it. So try to imagine if you have an old structure, but you need to carry more load or more frequency on the structure. That is a challenging part. I will highlight in next few slide. So this is give you an overview, the snapshot, the bridge asset in Victoria. In Victoria, we got the bridges and the covered about the 6,000 and other structure about 2,000, total 8,000. So this is give you an overview. Our bridges is about 3,200 and pedestrian bridges 120. Then the cover is 2,500. The rest one is like route-related structure, what I call is like major site structure, noise attenuation wall, retaining wall, etc. Just give you an overview of the asset management. When we look for the asset management, stakeholder expectation, when they invest the money, the return of investment, they want to get much better from year to year. For example, from year 0, they get the 6.5%, but come to the further year, they want to get the increase every year. But in reality, regulatory impact is decline because due to the standard and regulation requirement, documentation and reporting and operational practice, etc., or financial implication, they always is decline from year to year. So from the asset management perspective, how to bridge the gap? That is the main question. So this is to show you the asset owner want to achieve. Asset owner want to achieve is like when initial I spend more money, the risk I want much lower. That it makes sense. But when come to the further year, they want be more, spend the money much lesser. The risk, they accepted the risk increase a little bit further from the year 0. But the performance they always set at the center is meeting all the time the same. But in reality, infrastructure business or nature of the infrastructure business are quite different. When you spend more money, your performance is much higher. When you spend less money, the performance is much lesser, but the risk is much higher. So that is a reality. Compared to the asset owner perspective and the nature of the business, infrastructure business, they got adverse or got the gap inserted. So the most important key consideration, what are they? They are the important thing is a life cycle, cost, risk, and performance. That is quite important, or what I call is core consideration. But the important thing for this intelligent asset management coming in is how to do the optimization, how to central the key decision making, and how to do the systematic process. Right now, we move to the challenges in managing concrete structure. In challenges in the managing concrete structure is the aging infrastructure. In Victoria, 75 or 80% bridges was built in before 1975, which is about 50 years old already. And the other challenges is like deterioration factor due to the environmental exposure, load stress, and material degradation. Load stress is based on the vehicle. From here, you can see that in 1970 something, the vehicle is just less than T44, 44 ton or less than that, or MS18 or HS20. But right now, we got 160 ton. We need to design the loading up to full SM1600. And the other thing is a challenge is limited resources. Budget constraint, I think, is all the asset owner challenges. Every year they got a limited budget to maintain the structure. The other thing, the challenges is the expertise. Expertise in the bridges, in the different material, they need to really to understand the material behavior and the structure behavior in order to do the proper maintenance. That is the expertise, is the challenging. The other thing is the prioritization challenges. In the asset owner perspective, it's not only maintenance, they got other prioritization as well. So which one they need to do first. And the other challenges is the inspection limitation. As you know, that some of the traditional method, they got the challenges is like missing, like hidden defect. How can train the inspector well to do all this type of inspection? Next one I touch on is the intelligent asset management system. Intelligent asset management system, what does it mean? It's more on the integration of the data, technology, and process to optimize the asset performance and decision making. Because important asset management, like just now I mentioned, without the data, you can't really do the asset management. It's more rely on the data collection. But intelligent asset management system, we try to do the systematic approach and bring in the data and leverage the technology and come to a process to optimize the asset performance and make out the decision making. The component required is more on the sensor, data analytics, AI, and cloud computing. Bearing in mind all this component, they do have some limitation as well. The most important, you need to really understand what outcome you want to achieve in order to use this sensor or the component well. The most important, the goal is the predictive, the maintenance, and real-time monitoring and proactive decision making.
I'll follow the start, but when I'll have a look later.
Yep.
Ashish, could you please put your, thank you.
Right now, we move on to the key technology and the tools. The key technology and the tool is a sensor and IoT. This is all in here. I got the highlighted in black and red color. Black color, which we have trial or do the prototype testing or proof concept testing in Victoria. The red color is still working with the university under a research project. Sensor, the IoT is a structural health monitoring or real-time data on the bridge condition, which we have done. I will explain in my next few slides in the case study. And the data analytics is more on the predictive modeling, forecasting deterioration, which I will bring to the my case study as well. This data analyst for the predictive modeling, we use a bridge deterioration modeling, worked with the university 8 years ago to come out the model, utilize our inspection data. AI and machine learning is the pattern recognition and identify the trend and anomalies in the data. Also do the automated decision support. Digital twin is more on the virtual model, replicating the bridge condition for analysis and testing, and the scenario planning, simulating the intervention and their outcome. So for the case study one is a deterioration modeling approach of the bridges. This one is working with the university 8 years ago. The approach is like utilize our inspection data. For the inspection data, we can do either empirical approach or physical approach. If you use the physical approach, you get more accurate because you are very close to the structure. You can get the data you want. But empirical approach is more suitable for the asset owner who own a lot of structure. They can't really do the physical inspection for every single bridge. So they can use a whole empirical approach to develop a model and predict what the structure behave. This is one of the example would like to share. This is more on the probability value and the age year. In here, you can see the curve got the condition 1, that is a green color, condition 2, blue color, condition 3, red color, and condition 4, black color. Basically, for the H0, you can see that the structure is like a brand new, is the condition 1. Condition 1 means that no defect. Condition 2 is the minor defect. Condition 3 is the major defect. And condition 4 is the severe defect. So when you come to the age 20 years, you can see that the condition 2 is starting introduced, same as condition 3 and 4. So condition 1 is reduced. When come to the age 40 years old, you can see that condition 1 is getting less, condition 2 is introduced more, and condition 3 and 4 as well. So for this, the deterioration model will help you to predict what is the structure behave in the future. It also help you to predict the budgeting required to maintain or repair the structure. The deterioration modeling diagram basically rely on the inspection data. That is the level 2. What we call level 2 is a condition inspection, and also input in the significant contributing factor. They can be between 6 to 14. What are they? Then after that, develop the model. Then after that, they will come out the prediction condition output. The model need to refine it when you got the more data, and you can redefine the model, then you can get more reliable predicted condition. This is give you an overview how the thing look like. It's like if you look for the whole region structure, how many components they have, and number of the asset they do have, and how much the annual budget they have, and what is the total budget is required to maintain the structure. The other second one, the case study would like to share with you all is more on the Diamond Creek Bridge. This is try to use a sensor to study the new material and see how the structure behave. Diamond Creek Bridge is a two-span structure. It's a steel structure. It's 100 over years. We would like to use a carbon fiber reinforced polymer to strengthen it. As you know, carbon attached directly to the steel. If got the electrode, they can form out the corrosion. So what we do on this one is do the pre-stressed carbon fiber on the strengthening. This project is working with the EMPA at the Switzerland University and Swinburne and Monash University. And we install a sensor or the sensor on the carbon fiber to understand how the carbon fiber react and how the structure behavior look like. So after we install the sensor, we got the full load truck to pass through and to study the behavior of the structure. The third one is just a super load movement. This is more on the truck. It's an unusual truck or overload truck pass through the root network. How the thing look like, how to provide the support on the root network. This is a U-trough for the level crossing project because they cast the U-trough on the kill mall and they want to deliver to the Middleborough. So from there, they got the sixth structure is the substandard structure to allow the truck to pass through. In order to minimize the damage or prevent to do that, we install the sensor to monitor that. And this project is collaborated with the Monash University to work on it. So this is a bridge at here. They install the sensor to monitor the behavior of the structure. And this is the Kiyomo Iping. It's a U-trough. It's very old structure. Was built in 1950 something. And tried to monitor the structure is able to support the truck to pass through over the bridge. And this is a Banksia. It's a steel structure. We have to provide the temporary pop to support or strengthening to let the truck to pass through over. The next one would like to touch on the benefit and future trend. The future trend in the bridge asset management is more on the AI-driven maintenance. We need to increase reliance on the AI for automated decision making. Also, we need to leverage or utilize the integration of 5G. Because the 5G is coming up, they will enhance your connectivity for the real-time monitoring, especially if you've got the structure at the region or rural area, you can use that more stable for the sensor. And other one have to consider is the sustainability focus, prioritizing the eco-friendly material and the method. I think the most important, we need to bring everyone come in, the expert to come in to work together to get the project to implement. And the last one, just want to draw up the conclusion. The summary, a key point today, I just want to mention that intelligent asset management is important, but we need to know what we want to achieve. We need to bring all the expertise to come in to work together to achieve the goal. The final thought is the importance of adopting the new technology for infrastructure resilience. And the next step, we need to try and work together and implement it. Thank you.
Thank you, Yu. That was really interesting. I'm just keeping an eye on the time. We've got 2 questions in the chat, so we'll go to those now. And then we'll pass over to Shiva so she can present her presentation. So one of the questions was, how does the Monte Carlo work for risk assessment for the bridges?
Monte Carlo can be used to enter.
But there is someone's put an answer in there as well. Can be used to estimate probability of failure and then multiply it to cost or consequence. You will have the risk.
Answer is yes. The short answer is yes. That is possible. Depend on the data, how much data you have, and depend what type of structure you are considering. Either it's a simple or complex structure. So it's more on the data first thing. The other thing is like what approach you are going to use. Is you are going to use for all the simple structure only, or you are going to use all mixed together simple complex structure. So the thing is, the question is, the short answer is yes, but depend how you categorize and how you're going to approach. Yeah.
And there's one more question before we move on, which is are there any advantages between 5G networks and over 4G?
5G is more the stable on the network compared to the 4G, because the 5G itself is like what I understand from, I'm not in the IT area, from my colleague from the IT area, in terms of security wise, it's much better as well. So in terms of the stabilized, 5G is much better than 4G.
Right. Thank you. Thank you for that presentation. So we're going to move over to Sujeeva, who's going to do a presentation on digital twin and reinforcing concrete infrastructure for intelligent asset management. Sujeeva, would you like to introduce yourself? And I'll just remind everyone, for those who came in a little bit later, if you have any questions, just put them in the chat. We'll make some time at the end of the presentation to ask those questions, but we'll also make some space to talk about where those research gaps are, how we might do that translation between the research and embedding that into industry, and there might be some time for other discussions. So happy to make the space for that. So I'm going to hand over to you, Sujeeva.
Thanks a lot, Lee. Thank you. Great presentation, Eugene, as always. You set the scene very well for this presentation. I hope everyone can see my screen. I am Sujeeva Setunge. I'm a professor in civil engineering. Also, I look after the research portfolio of science, engineering, computing, and health at RMIT. I'm also a director of the ARC TREMS Hub. I also want to acknowledge my colleague, Dr. Mojtaba Mahmoodian, who is the co-lead of the project, Digital Twin of Reinforced Concrete Infrastructure for Intelligent Asset Management. So I'll start with a quick acknowledgement of the country and RMIT University, where I work, we acknowledge the people of the Woy Wurrung and Boon Wurrung language groups of the Eastern Kulin Nations, on whose unceded lands we conduct the business of the university. I also respectfully acknowledge their ancestors and elders, past, present, and emerging. I would also like to acknowledge the traditional custodians and their ancestors of the lands and waters across Australia, where we are joining from today. Moving on, before I move on to the project, just want to acknowledge the great support from our partners. We have 4 universities and 10 industry partners in this project. It's a huge group, and I'm also pleased to say that we have research leaders covering all different aspects, the best people in Australia in this project. So the research partners are RMIT University, Curtin University, University of Technology Sydney, and Western Sydney University. And we do have the 2 transport authorities in Victoria and New South Wales, and also a number of other industry partners. So conscious of the time, so I'll move very quickly through the research program. So the major objective we had, now, Eugene set the scene very well. So we did a significant amount of work with the Department of Transport, with Eugene, on deterioration modeling. So we developed the Markov process-based asset management predictive modeling approach for Vic roads based on level 2 inspection data. So, and then the authorities also have a separate process for load rating. So the vision we had when we started this program is to develop a complete digital twin package, which integrates the structural health monitoring, deterioration modeling, visualization, non-destructive testing, and also deep learning. Creating this digital twin or digital replica of structures and showcase the integrated technology on 2 case study bridges. So this is a very ambitious target, and we had brought a number of different elements of research together to achieve this. So if you look at some of the boxes around the central target, you'll see monitoring and simulation, optimum sensor configuration and real-time modeling, development of sensors, which you don't usually have, and then looking at visualization, drone inspections, terrestrial laser scanning, and then crack detection, deep learning to identify damage and detect damage, and then intelligent decision making and failure prediction for maintenance optimization. So that's the plan we had. So when you look at the integration of colleagues from different research institutions, research teams, and also our partners, this is a complex picture. However, if you divide it into several parts, so we do have health monitoring, visualization, and asset management component undertaken by RMIT, then visualization, specifically laser scanning, and also parts of modeling undertaken by Western Sydney University. University of Technology Sydney specializes on deep learning for crack detection, and then Curtin University focuses on non-destructive testing, damage detection using laser scanning. So we have our respective partners helping us with different aspects of this research program. And the challenges we encountered are quite significant. So the research challenges identified are in the first place, optimized sensor placement. So what we were looking at is structural health monitoring is normally implemented in landmark structures. It is not anything new. We do have these implemented in landmark structures, and we do have numerical models linked to the sensors. So what we were looking for is technology that can be deployed across a large number of structures. So in order to minimize the cost and optimize this design, we had to look at the optimized sensor placement. We had a PhD candidate in RMIT looking at this. And then, of course, numerical modeling and field validation. Now, I just want to mention that this is, again, modeling and validation has been undertaken by others. But what we were looking for is a model which then can be queried to interpret the sensor data. So we were looking at reverse order finite element analysis for interpreting sensor data, and then connecting the numerical structural model to visualization platform, deep learning for damage interpretation, non-destructive testing to complement the digital twin, and also regular validation, calibration, and then low-cost embedded sensor technology for early warning and durability. Now, this is a gap which we identified through our early literature review. And then integrated asset management platform, which can bring all this together. So we started with a simple structure in lab and field. So looked at the laboratory-based structure and very simple steel structure to see how we do this reverse engineering or reverse understanding of the sensor input interpretation so that you can feed into asset management. Subsequently, we used the steel structure provided by one of our partners, Beta International, to Dalrymple Bay Coal Terminal. This was undertaken by Moshtaba and one of his PhD candidates. Steel structures are easier to analyze than concrete structures, so we started with something known before we moved forward. So at this stage, what we also figured is that so live real-time finite element analysis can be quite time intensive and also expensive for a partner. And we looked at artificial intelligence as a possibility to enable us to have this understanding of sensor data and then interpret them in a reasonably fast manner. So that's what we have moved forward with, and that was a PhD project again at RMIT. So with our two partners in the road authorities, we were able to secure 2 bridges as proofs of concept. One is the Boronia Bridge in Victoria, and the second one is Bridge over Bunurong Outfall Canal in New South Wales. So the Victorian Bridge is provided by Department of Transport Victoria with Eugene help, made Major Road Projects Victoria. And the second bridge is provided to us by Harish Sivastra from Transport for New South Wales. Want to gratefully acknowledge their support. So what we started is, okay, first you need to come up with a model, and typical fast method of validation is using the dynamic response. So the modeling has progressed with significant input from partners. The drawings have been provided. So we have been able to develop a reasonable model for dynamic response, and the colleagues went into the field, and we worked with Department of Transport for traffic control, and with their support we have been able to validate the dynamic response of the structure, which gave us a reasonable confidence about the ability to simulate the structural response. So I just want to say that when we were selecting a structure to simulate, we also identified concrete girder bridges as the cohort of structures we want to work on for this project, and they are the type of structure most commonly used in road authorities, and we thought if we can get these understood reasonably well, we can move forward. So during the validation, we observed that we have a reasonable degree of accuracy to give us confidence to move forward. And then the next stage we have been working on is identifying what's the best method of instrumentation. So we've trialed a number of different methods of instrumentation. Now we did instrument the bridge for dynamic validation with accelerometers, and for this second stage where we are installing sensors which should remain for the life of the bridge. We had a number of challenges. One of our partners was supposed to provide us with the sensors, and we did have some issues with sensors. Now we are moving forward with wireless sensors for the Boronia Bridge. So the next challenge you face is you instrument, you have your physical instrumentation, then you need the connectivity, and you need a real-time platform and to link to the virtual world. So we do have cloud access through our asset management platform developed previously by RMIT, which is hosted in AWS. So we do have access to the cloud, and this is what we will be progressing with. So the second stage of modeling now is being completed to interpret the sensor data. So as I mentioned previously, the plan here is that you have the sensors installed, your model is creating the numerical representation of the structure, and then with the artificial intelligence where if you run a number of simulations and create an adequate database, you can use AI to interpret the sensor output so that the road authority can have a very reasonably fast information from the digital twin. So the other element of the project is looking at development of a durability sensor. So here the expectation we had is that for most durability sensors, we do have the output. Usually the condition inspections actually receive the information quite late during the degradation process. We were looking for a relatively inexpensive sensor which can be thrown into concrete, which can be interrogated later to determine the the chemical changes within concrete so that you can have early warning when a structure is undergoing some degradation. So embedded and wireless is the criteria I've given. So I've asked distinguished Professor Anand Mitchell, who is working and leading this stream of the project, to come up with something which is inexpensive but gives us warning quite early. And this is what they are currently working on and looking at RFID technologies for this purpose. And they are currently working on a number of different options for validation. Now, visualization is the second element of the project, and Western Sydney University team led by Professor Bijan Samali, Associate Professor Maria Rashidi, and the fellows and students are leading this aspect. They not only have the expertise in visualization, which forms a major part of the project, creating the 3D visualization and using UAVs and terrestrial laser scanning to get the visual images required. They also have the understanding of the numerical modeling validation aspects of the digital twin as well, which is very valuable because the understanding is very important in this aspect. So the Curtin University is contributing in non-contact laser microphone system for concrete inspections. Now, this is another very important part of the project, developing a pulsed laser microphone system for generation and reception of acoustic waves. So the damage detection can happen in for different types of damages as shown here. And you have a concrete specimen and with different embedded steel bars, and also the different types of damages which are being trialed in the laboratory for damage detection using the pulse laser technology. The project is led by Professor Abhijit Mukherjee and the research fellow Dr. Subra Maji. So they are progressing this. Now, the way this fits in the whole project is that once we have the visualized system, digital twin system, we will require regular validation, and the non-destructive testing technology method Abhijit and the team are developing is very valuable in that sense. Now, University of Technology Sydney is contributing in deep learning assisted concrete crack detection using computer vision, and the team lead is Dr. Yan Cheng Lee, and he has been developing applications for deep learning for different types of concrete crack detection. And they also are looking at quantifying the crack morphology, crack segmentation, and then also identifying or understanding the remaining or residual life of concrete structure using crack morphology and the trained models. So this is a significant piece of work which contributes to this puzzle of optimized or intelligent management of concrete structures. Now, finally, I just want to say that some of the work Yuchin presented earlier about stochastic data-driven predictive models, these are embedded in a cloud-hosted asset management platform, which RMIT developed. We call it CAMS, Central Asset Management System. Now, the system can divide a bridge into individual components, and for each individual element, we have stochastic data-driven predictive models to predict the degradation with time. We use the discrete Markov process, and we have developed the transition matrices for 75 elements in bridge inspection manual for this purpose. We've also created a mobile app for data collection. So the Central Asset Management System is currently commercially deployed for property assets by RMIT University. However, we do have an all assets version which includes the bridges. And the expectation we have is with the knowledge we are acquiring from the project, we will be able to derive more physical predictive models, which can be integrated into the system instead of the data-driven models, so that we could actually have a more evidence-based predictive modeling approach for reinforced concrete structures. So the models we developed have been included in DTIM's modeling asset management platform. However, we do have the central asset management system incorporating these models as well as a standalone asset management platform. So what does CAMS does? So it actually predicts when to spend, how much to spend, and how to spend smart. And it also allows an organization to align to a risk appetite they may have for a given budget. So we basically predict the life cycle change in condition and life cycle cost. And you can pick the risk threshold you want to select, and also for a given budget availability, you could also predict the maintenance actions most suitable for the organization. So finally, thank you very much for listening, and I'd like to acknowledge the whole team. So this is a large team. We have the research team and also our industry partners who we are very grateful for. Thank you, Lee. I will stop at that.
Thank you.
Very happy to answer any questions.
Sujeeva. You can see without seeing that last slide, you can see how many people have worked on that piece of work. Like it's amazing. Does anyone have any questions for Sujeeva about her piece of work? Just having a quick look in the chat to see if there's anything. Maybe what might be what I like to do in my workplace and with Harish. Oh, you'll have to speak into the microphone a little bit.
Just 2 seconds.
I think that's better. Yep.
How about now? You can hear me?
Yes.
Okay, so it was just a comment. Probably thanks for Sujeeva and her team for doing brilliant work on this particular project. And I guess every time I turn up into steering committee meeting, I see some good progress. So I think big thanks to the whole team and Sujeeva's capable hands for managing this large multi-stakeholder project.
Yeah. Yeah, and I think when you do take that kind of multidisciplinary approach, you get much better outcomes because you've got those different stakeholder lenses. You can really focus on the challenges that are being solved and create something that's useful for multiple people. I do have a question for both presenters. It'd be good to understand what were some of the lessons learnt along this whole process, and how might people do things slightly differently just to progress this sort of project a little bit faster in the future? Sujeeva, I'll get you to go first.
Okay, thank you. Thanks, Lee. Yeah, it's been a great pleasure to work with the partners because at every committee or progress meeting, we get huge amount of feedback, and both DOT and Transport for New South Wales set us straight if we make an assumption which is inaccurate or incorrect. So I'm really grateful for that. So that collaboration is a key in progressing this. And I believe a translation is a very important element of it. So we are currently building on the digital twin system. So as we move forward, this considering the ability to implement it and opportunities for implementation and utilizing it effectively is very important for us. So the decisions made during the research stage will impact on that ability to translate fast. I also see a question in the chat, Lee. Is the data collected continuously out in the field? Yes, the answer is yes. So when the digital twin system is in place, which is what we are working towards, we will have a live system which is collecting data regularly. So that's the expectation. So if there is an anomaly, the authority will be able to see that through the data, changes in data. So we can set alerts up for changes in the observed data and the interpretation from that. I'll pass on to you, Chin.
Yeah, thanks, Sujeeva. Thanks, Lee. I think the most important need to demonstrate what is the value and what is the problem from the asset owner perspective, and also have to think about their transition with the existing practice to the new one may involve in the change management or involve in their platform changing, how they're going to approach that. So that is need to think about the staging to work toward. So the other thing is need to think about the expertise in the asset owner area, because on this new technology with the existing expertise, can they handle it? If not, what are the gaps? They need to address that. So in order to work that one, what I see is more on the two-side thing, need to address what are the gaps and map out, and from there move forward. One thing is like some holding back is say, well, we need to see other to do it. If we don't start it right now, we start later 10 years, we still need to go through the same process. So we need to start somewhere. So in order to encourage that, is just a map out and see what we need to start first and what we are going to achieve in every staging.
Thank you. Thank you. And I guess, where do you see this going in the future? Like how right now we're looking at bridges. I see multiple opportunities in different areas across infrastructure, but I'd like to hear from the two of you in regards to where you think this can be, I guess, picked up and dropped into or translated into.
Yes, thanks, Lee. I think one of our largest portfolios utilizing the CAM software is the hospital sector. So the next project we are thinking of is creating a digital twin of a hospital. So bringing our colleagues in health and artificial intelligence in. So that's something we are currently working on, because the property sector is that has taken the system quite well, and then digital twin is the natural progression into the next stage. So it's quite exciting for us to progress this project. So we are learning a lot through this process.
Chin, a question's just come through. So before I go to you to answer that question, I want to be, we've got 5 minutes left. Is there a long-term goal to use this technology to replace or reduce traditional bridge management processes, such as regular visual or tactile inspections?
I would think so, to be honest, because this day technology can replace to the human, and the other thing is the minimize the human error as well, especially the structure in the remote area or regional area is very hard to go or travel to inspect the structure. By using this technology will save a lot of time and the cost effective. The other thing I see on the high risk structure, we take it as granted. We know that the structure in the risk, but we just hope everything go well. But by using this technology, we can identify what is the risk and where is the category, where are they sitting, and will trigger out the defect and do the repair immediately. So this technology in future, I can see more and more to use it to manage the risk and also streamline the process.
Yeah, I
Yeah.
agree with that. Reducing that risk, knowing that, or that future planning. Sujeeva, what your thoughts?
Yes, I think we probably will need to go in stages. Initially, I was thinking Department of Transport has monitoring inspections. I think Eugene might like to expand a bit more, but where you have these vulnerable structures identified and they have a regular inspection program in place. So these are the other cohort. Possibly we can commence implementation of the technology on, because then you really you can reduce the frequency of inspections if the data will give you a mechanism to minimize the risk of these structures as well. It is just my thoughts as a researcher, but very interested to hear the opinion of the practitioners.
Yeah, what I think is this one need to be asset owner have that system and the big data collection in their portal, because this is a game changing if you adopt this technology. And the other thing, existing practice versus this technology is a new practice. They need to come sort of the new inspection approach or new inspection manual, or train the inspector what they have to do. And they need to have the expertise to handle the data as well.
Yeah, and I think like it is hard to have a financial return on investment around that risk space, but that really takes the pressure off to focus on where you need to focus on and planning for the future. So I think, they're both really important points. We have 2 minutes. I really want to finish on time. Does anyone have a burning question before we sign off? No? Well, I really want to thank everybody for attending our community of practice today. It's the biggest one that we've had so far, and I think it really speaks to our presenters that we have in our teams today. So thank you, Yu Chen, for your presentation, and thank you, Sujeeva, for your presentation. I really look forward to seeing how that research and that piece of work translate into the real world. And, I can see things, I can see how it might translate into the water industry as well. We spend quite a bit of money trying to keep up with risk versus asset management versus cost of maintenance. So I think it's really a piece of valuable work. So thank you for your time. Thank you to everyone for your time. Have a great day, and hopefully we will see you at our next community of practice. Thank you.
Thank you all.
Thank you, Lee. Thanks to Smart Grid CRC for funding the work and also this arranging of the COP. Thank you.
Thanks all.